Okay, in this video I'm going to explain the concept of the binomial theorem. As we previously learned, if we want to expand a binomial, we can make use of the Pascal's triangle to get the coefficients of each term of a binomial expansion. Now, the Pascal's triangle can be uh, a practical method if the exponent is not like a big number. Say, if I have to expand x plus y to the fifth, I just need to reach the set of numbers in the Pascal's triangle that will give me the coefficient for the expansion of x plus y to the fifth. And that will give me 1, 5, 10, 10, 5, and 1. Okay, so this will lead me to the expansion. So we have 1, 5, 10, 10, 5, and 1. Now, the problem with this is, what if the binomial is already raised to an exponent raised, let's say 20, and we're not actually interested in the expansion of this, but rather we just want to find a specific term. Okay, so we don't want to create a set of numbers until we reach the numbers for the 20. Hence, we need to know the binomial theorem. Okay, so how does the binomial theorem work? Okay, so let me explain that in a while. Okay, let's copy the numbers again for the x plus y to the fifth. So on the x plus y to the fifth, we will be having 1, 5, 10, 10, 5, and 1. Now these numbers are actually coming from a, or can be obtained from the combination formula. And this is simply 5 combination 0, 5 combination 1, 5 combination 2, 5 combination 3, 5 combination 4, and 5 combination 5. If you're familiar with the formula, this will lead to every number in this set. Okay, 5 combination 0 is 1, and so on. Okay, in general, the combination, just a recap, so n, then any r, so this is equal to n factorials over r factorials times n minus r factorials. Okay, so it seems like a bit complex to see a lot of letters in the formula, but just to give you an example on how to get 5, 1, okay, so it's 5 factorials over 1 factorial, and then 5 minus 1 factorial is 4 factorials, and this will be 5 times 4 times 3 times 2 times 1 over 1 factorial is 1, and then 4 factorial is 4 times 3 times 2 times 1. Now, as you can see, this set of numbers will cancel, and you will get 5 over 1, which is equal to the 5, the one that we desire. Now, other people would take combination this way. Like if I have 5 taken 1, then I'll just have 5, and then I have the 1 times, so 1 factorial times 1. So you start with 5, and then since you only have 1 as one number, you only use it once, so 5. Okay, so like if I have 5 taken 2, so I have 5 times 4. Okay, so I'll stop there. I have to use only up to 2, and then 2 factorials is 2 times 1. And then when you simplify this is 20 over 2, and this will give you 10, which is the value from here. Okay, can you see that? Okay, here. Now, so just to make the story short, okay, so if I want to get the coefficient of the expansion, so I'll make use of uh, this formula NR, okay, and you can do like any method here. If you have a calculator, actually this can be obtained easily, okay, just plug in the corresponding number, just push the button for the combination, and this will give you. Now another important thing that you have to note is that it has some pattern in terms of how the numbers are related to every term. Like if you notice, the first has a 0, so first term, second term, third term, fourth term, fifth term, and the sixth term. The second term will have 1, the third will have 2, the fourth will have 3, the fifth will have 4. So the number below is always 1 less than the given term, okay? So on the fifth term, okay, the value here, the value like here is always 1 less than the given term, so 5, and then this is 4, okay? So that will help you understand how to generalize the formula, okay? Now I'll stop my explanation of the combination there. We will focus on how to expand the binomial. Okay, so let's take a look at the expression again. So if I have to expand x plus y to the fifth, then so this will be 1, okay, so 1, 5, 10, 10, 5, and 1. Okay, and if you remember the pattern that we used before for the Pascal's triangle, so x starts with the fifth, and then to the fourth, and then to the 3, and then square, and x until there's no more x. And in the same way, y, so there's no y in the first term, the first y will appear in the second term, and then y squared, y cubed, y to the fourth, and y to the fifth. Okay, so this is all plus because this is x plus y to the fifth. Now, what we need to focus on is, remember to create the formula for finding the terms. Now if you take a look at let's take one of the terms, say this example. Now a while ago we were talking about the combination formula, is that, okay, so let's have 10x cubed y squared. Now the 10 came from 5, so this is first, second, third, so the number here should be 2. And then if you take a look at x and y, you could somehow get this exponent just by looking at this. Okay, so one can deduce that 3 is 5 minus 2, and then 2 is whatever the number here. Okay, this is actually the concept of the binomial theorem, that you could get a specific term easily. Okay, now to generalize our findings, you can do that to every term. To generalize our finding, okay, so we have an any term, so let's call it the r plus 1 term. Okay, I'll show you later why we call it r plus 1 term. So this can be, so any n given, and then remember the fifth term will have 4. Okay, I'll get the number 4 below here. So if I have r plus 1, that's one more r, then the number should be r. And then the x will take, so from 5 minus 2, deducing that this is n minus r. So you subtract the 5 and 2, 5 n minus r. And then the y will take the value of r. So this will give us any term in the expansion. Okay, so just to explain it further, so if I want to find the first term of an expansion, say an expansion, then that would be n. So first term, so meaning it's r plus 1 term, so this number should be 1 less than the side term. So if I have to find the first term, okay, so then x, and then n minus 0, and then y to the 0. That's how you find the first term. Okay, Now let's see what if I have like, let's apply this. I have, let's verify rather. So from here, we could see that the second term of x plus y to the fifth is 5x to the 4y. Okay, so second term is 5x to the 4y. Remember, we are expanding x plus y to the fifth. So this is the second term. Now the binomial theorem will validate this. So 5 came from, so n is 5. Remember, this is always the n. 5, so this is the second term, so 5, 1. Then x, 5 minus 1. And then y to the 1, which is exactly this. Right? If you simplify, compute 5, 1, you'll get 5. X to the 5 minus 1 is x to the 4th. Then y to the 1 is 1. So that's how you get the term, the second term in the expansion of x plus y to the fifth. Okay, so this is the binomial theorem. It allows us to find a specific term by using this formula. Okay, before I end the explanation, let me show you an example. Suppose I want to find the 11th term of x plus y to the 20. So I want to find the 11th term. Okay, so I have 20 is my n, so 20, 11th term means I have to subtract 1 for the r, so this is 20, 10, then x to the 20 minus 10, and then y to the 10. And then just compute for the value of this. I will not do it here anymore, but you can compute for the exact value of 20 combination 10. This is x to the 10, and this is y to the 10. And this will be the 11th term. That is just looking for one term. So if I have to find the expansion of x plus y to the 20, all I have to do is find the first, find the second, find the third, find the fourth, and so on, using the same formula. Okay? Now the advantage of the binomial theorem is that I don't need to create my Pascal's triangle just to get the numbers set for the exponent 20. Okay? So just to summarize it, okay, the binomial theorem states that the r plus 1 term can be taken through the formula nr, combination r, x to the n minus r, and then y to the r, coming from the expansion of x plus y to the n. Later on, you will see some expression in which this is no longer x and this is no longer y, but the idea will remain the same. Okay, that's it.